In this video, we will be discussing a very important concept that is called photoelectric effect. Okay, important from the NEET point of view, J point of view, as well as J advanced point of view also. So, let's start the discussion of photoelectric effect. Okay, photoelectric effect. Now, first point, you have to remember that this phenomena was observed by which one? By whom? Hertz. Okay, same Hertz, yes. Amount, unit of frequency, that one, that same person Hertz. He observed photoelectric effect. So why Einstein is popular? So Einstein is popular with photoelectric effect because he explained it. He explained it using the equation and all that, as well as we all know that Einstein won the medal, Nobel Prize, not only any medal, but he won the Nobel Prize for photoelectric effect. Okay, so let's start this phenomena. So suppose I have a metallic plate. So on this metallic plate some rays are falling. Okay, so these rays are incoming, their energy is h nu or hc by lambda. So when these rays are falling on this one, so they will knock out the electrons. Electrons will get the energy and it will come out with some kinetic energy. Okay, now in the experimental setup, this electron will travel to the other plate, that is called collector plate, and this will constitute a current, and that current is called photocurrent. Clear? Radiation is falling, so radiation is falling on the photosensitive plate. Electron will absorb those radiations and they will come out of the metal with kinetic energy. So Einstein equation is that incoming radiation, how much? H nu, that will go into two things, phi plus k max. So incoming radiation will go into two part, where phi is work function. What is phi? Work function. How to define it? Minimum energy. Work function is what? Minimum energy to take out electrons. So if radiations are coming and falling on the atom, falling on the metallic plate, the electrons will absorb those radiations and some of the electrons will come out. So the minimum energy required for the electrons to come out will be called work function phi. Okay, now those electrons which are coming, they will have some energy. So if you talk about photoelectrons, electrons will have energy between anywhere 0 to maximum. 0 to maximum. So if I talk about equation, so equation will be h nu equals to phi plus k max. So the question is that does each of the electron will have the maximum kinetic energy? Every electron? No. So this is not applicable for every electron. So only those electrons which are having maximum kinetic energy. Maximum kinetic energy means these electrons will undergo the least deviation, least collision, or they will not go any collision at all. They will absorb the radiation and they will just directly come out from the metal. Okay. So this is our equation. Now phi max, if I talk about phi here, so phi is the minimum energy, work function. So work function can also be written as h nu naught, or it can also be written as hc by lambda naught. H nu naught here, what will be the nu naught? Nu naught will be threshold frequency. What it will be? Threshold frequency. Similarly, lambda naught, it will be threshold wavelength. Threshold wavelength. Okay. Okay, this is clear. Now see, if the electrons are coming, if the electrons are coming out with some energy, so there will be some reading of current. Now if we apply potential in opposite direction, we know that suppose these are the electrons, these are moving with k max. If you want to stop this electron, you will have to provide a potential, opposite potential. So if the potential is V naught, so we can say that k max kinetic energy will go to the potential energy, that is EV naught. So k max can also be written as EV naught. Now h nu equals to h nu naught plus EV naught. So multiple formats can be given for the formula. So you do not have to worry about the format. You just remember the basic equation and how to convert each of them, that you should know. So basic equation h nu equals to 5 plus k max. One simple equation. This h nu can be written as hc by lambda also. This phi can be written as h nu naught or hc by lambda naught also, and k max can be written as ev naught. Now you see permutation, combination, and how much possible equations are there, but you do not need to remember those equations. Simply you can replace the values and you can get it. Okay, let's move forward with some point related to photoelectric effect. Okay, now there are two things associated with radiation. So there is one thing called frequency and there is other thing called intensity. Okay, important discussion. If I talk about frequency, so if you increase the frequency, energy of the radiation will increase. If radiation energy is increasing, means photon energy is increasing. Energy of the photon is increasing. Now more energy to photons means electrons that will come out, they will also have more energy. So energy of the photoelectrons will also be more. So in order to stop those photoelectrons, more potential will be required. So stopping potential will also be more. So this is the whole effect of frequency. If you increase the frequency, then energy of the photons will increase, energy of the photon will be energy of the photoelectrons will also increase. So stopping potential will also increase. Important point, there is not direct proportionality, like if you increase the frequency, energy of the photon will increase, but energy of the photoelectrons will not increase. So this is not true. Very important. Frequency is proportional to energy of what? Energy of photons. But when those photons transfer the energy with electron, there is no direct proportionality between frequency and energy of photoelectrons. Okay. Similarly, if I talk about intensity, so if you are talking about intensity, so we can say that for intensity, if you increase the intensity, you will increase the number of photons. Number of photons that is falling, that will increase. If more photons are falling, so there will electron will also be more. Here it was energy, here it is energy of photoelectrons, but here it is number of photoelectrons will increase. If number of photoelectron will increase, it means that photocurrent will also increase. Photocurrent will also increase, but energy remains what? Energy same. Energy has nothing to do with intensity. So when you increase the intensity, energy will not change. Energy of the either photons or the energy of the photoelectrons, both will not change. Here we can say that there is a direct relation of intensity with current. Direct relation intensity with current. Intensity is proportional to what? Current. So if I draw the graph of intensity versus current, so current versus intensity, if I draw the graph will be straight line passing through origin. Clear? Okay. Once again, frequency, if you increase the frequency, then energy of the photons will increase, means more energetic photons will come out. if photons are more energetic, they will eject eject the electrons, and electrons will also have more energy. So electrons, number of electron will remain same this time, number will remain same, but whatever electrons are coming out, they will come out with more energy. So if energy of the electron is increasing, in order to stop them, more potential will be required. So stopping potential will also be more. Here there is no direct proportionality, does not exist between frequency of photons versus energy of electrons. Okay, but for intensity, if I talk about intensity, if you increase, number of photons will increase, correspondingly number of electrons will increase. If more electrons are coming out, more electrons will reach the collector plate, so intensity, so current will also increase, photo current will increase, but energy will remain same. So simple, frequency has to do with energy, intensity has to do with number. Frequency with energy, intensity with number. Assume it like two buttons. Okay, like this is our source of radiation. So here we have two buttons, one button is for frequency and one button is for intensity. So if you increase the frequency, then energetic electrons will come out. If you increase the intensity, then number of electrons will be more. Okay, simple discussion till now. Okay, now, so we are talking about photoelectric effect. So we saw that explained by observed by Hertz, explained by Einstein. Okay, then we saw that equation of photoelectric effect, h nu equals to h nu naught plus k max. This is threshold energy. Now we saw that intensity is proportional, current is proportional to intensity. Okay, one more, now more points. What we can say? Okay, photoelectric effect is explained by, or photoelectric effect is a proof of particle nature of light. It supports which nature? Particles nature of light. Photoelectric effect supports particle nature of light. Okay, next point. No time lag is there. There is no time lag between absorption and photon, absorption of photon and ejection of electron, and ejection of electron. Okay, so the moment electron absorbs the photon, it will come out. Next point, photoelectric effect will only take place when frequency of the incoming radiation is more than the threshold frequency. Okay, when frequency of radiation is more than threshold frequency, only in that condition photoelectric effect will be observed. Okay, there was a question based on this one. So the question is saying that frequency equal to 1.5 f naught. Okay, we are giving a frequency of 1.5 f naught. F naught is the threshold frequency. Now if you half the frequency and double the intensity, half the frequency and double the intensity, half the frequency and double the intensity. So what will be happen to the photo current? What will be the effect on photo current? Okay, simple question. What we have done here, frequency was given 1.5 times threshold frequency. What we are doing, we are making the frequency half and doubling the intensity. Okay, okay. Now frequency, what it will become? If you half it, it will become how much? 1.5 by 2 f naught. Oh, it will become how much? 0.75 f naught. So this is our frequency. Now tell me, more than or less than threshold frequency? More than or less than threshold frequency? So our frequency becomes less than threshold frequency. So photoelectric effect will be shown or not? So no photoelectric effect will be shown. So what about current? There will be zero current. Okay. Okay. Let's move forward. Now let's see the variation of various other parameters or the important graphs that we have to see in photoelectric effect. First graph we have already seen. The first graph is between photocurrent I versus intensity capital I. So we have seen that photocurrent will be proportional to intensity. If you increase the intensity, then photocurrent will also increase. Yes, under the condition such that frequency is greater than threshold frequency. Under this condition only this graph is valid. Proportionality is there. So proportionality means straight line passing through origin. Okay. Graph number 2. Current versus potential. Current versus potential. Okay. So at the point when current becomes zero, that potential is called stopping potential. So the point when current becomes zero, that potential is stopping potential and it will be negative direction. So somewhere here is the stopping potential, and if you increase the potential in the forward direction, the current will start to increase somewhat like this, and after some time it will saturate to a maximum value. Okay. Saturate means after some point of time. Your potential when you are increasing, no, means you are supporting the electron, you are helping the electron from the emitter plate to the collector plate. So electron is going from emitter plate to the collector plate and you are just helping them. You keep on increasing. You can only help if there is someone asking for help, right? If electrons are asking for help, then only you can provide potential and you can make them go to the other plate, so the current will increase. But after some time there will be no electron available, no extra electrons will be available, no. So if there is no extra electron available, means no matter how much potential you increase, current will not increase after a particular value of time, after a particular value of current, and that current is called saturation current, maximum current, saturation current. Okay, this is the graph. Now in this same graph we will study the effect of two things. Let's say 2a we are drawing. 2a means on the graph, in the same graph we will study effect of what? We will study effect of frequency. Okay, effect of frequency. Now see, one graph is there, it looks like this, like this. Now if you increase the frequency, tell me what will happen. So if we increase the frequency, what will happen? So when we are increasing the frequency, then see, number of photons will remain same. So if number of photon remains same, then it will hit the electrons, so number of electrons will also remain same. So number of electron is also remain same, means same number of electron will go through the collector plate, so current will saturate at the same value. So when you increasing the frequency, saturation current does not change, but then the same electrons that they are coming, this time they will be more energetic because frequency is more, so photon energy was more, so they will transfer more energy to electron, so electron will come out with more energy. So if electrons are coming out with more energy, if we have to stop those electrons, more energy will be required, so stopping potential will become more. Okay, so second frequency, I draw the graph like this, it will almost saturate at the same level. Similarly, if I talk about more frequency, third frequency, it will saturate like this. Okay, frequency f1, f2 and f3. So here stopping potential for the third is more, means third frequency was more than second frequency, more than first frequency. So this is effect of what? Frequency on, sorry, current versus potential curve. Current versus potential curve. Okay. Moving forward. 2b. On the same graph, now we will study the effect of intensity. Effect of intensity on current versus potential graph. So current versus potential graph looks something like this. Okay. If I talk about, if I increase the intensity increase, so what will happen now again? If you increase the intensity, more number of photons will come. If more number of photons are coming, they will collide with more number of electron. More electron will come out, but the energy of electron will remain same. So in order to stop those electrons, energy will require same. So stopping potential will remain same. Stopping potential will remain same, but this time more photons are coming, so more electrons are coming to the collector plate, so current will be more. So energy or stopping potential will remain same, but now they will saturate at the more level. So let's say this one is for current intensity first, second intensity, third intensity. So we can say that third intensity has more, is more as compared to second one, is more as compared to first one. This is the order of intensity as well as the respective graph. Okay, these three graph clear. Let's move forward to the next graph. So the next graph is between stopping potential versus frequency. Stopping potential versus frequency. Okay, so let's see the equation. H nu equals to phi plus k max, that will be EV naught. So if you write EV naught, it will be H nu minus phi. So V naught will be given by H by E into nu minus phi by E. This is our equation. So V naught we have plotted on the y axis and frequency on the x axis. So y equals to mx plus c. So the graph is following the nature y equal to mx plus c. So it will be a straight line. Okay. What is the slope of the straight line? H by E. What is the intercept? Minus phi by E. So somewhere here it will go intercept. So the graph will start from here. And this frequency is called which frequency? Threshold frequency. Because after that only photoelectric effect will be observable. Okay. Slope of this line, if this is theta, so slope means tan theta, and slope will be given by H by E. If I talk about this intercept, this intercept will be phi by E. Okay. Now if you draw this graph for multiple metals, so for various metals the slope will remain same, so the graph will be parallel. For example, I have plotted one more graph on the same line. So for this is for metal A, this is for metal B. So tell me which metal is more photosensitive? More photosensitive means work function will be less. Photosensitive more, work function less. Which one has less work function? A. So A is more photosensitive as compared to B. Okay. So this is the discussion regarding photoelectric effect. Now you go through this lecture, revise it 2 to 3 times, and then we will be solving a lot of questions to practice the whole concept in a different separate video. Okay. Okay, thank you very much for joining in.